Welcome to Try Right. Today we will be learning and knowing about multidimensional arrays and matrix operations. In Java, we have arrays which can go in one dimension following x or y. Similarly, we can go in two or more coordinates, or will be recording two or more dimensions following different coordinates. The most commonly used are 2D arrays, which are used to represent matrices. In multidimensional array, multidimensional array in Java, we simply say it's an array of arrays represented by. It can be represented in Java. The 2D arrays can be represented as, we have to write the different data type. Integer, suppose it be integer type, data type, which is the most common. We will be following for open and close square braces, then again open and close square braces. This, we should be giving a variable name to this matrix, matrix matrix equals within the curly brace. We should be writing this within the curly brace, and we have to form two matrices. So in addition, we will be writing two curly braces inside, open and close curly braces, differentiated, both separated by comma. Both these curly braces are separated by comma. Now we know these are the different matrices, so different operations can be obviously performed on this, such as matrix or addition, matrix subtraction, matrix multiplication, matrix transpose. So this is it, and we will go for different tasks accordingly. Now we will go here for a task. So for performing a task, we need to go to Eclipse. There we need to go to our folder try right, and then we will make class. We will be making a transpose of our matrix. We will be making transpose of our matrix. So we will be naming the class. We will be going to new, and then we will be going to the class and naming it as matrix transpose. Matrix transpose, matrix transpose. The first letter should always be a capital letter. Of the class, the first letter should always be the capital letter. Now, in order to perform the performance operations, we need to write public static void main and the various code. We will be writing public static void main string args and following everything in the curly braces inside. First, we will initializing and declaring two matrices. First, we will initializing our matrix. Here, the matrix is as follows: 1, 2, 3, 4, 5, 6 inside the data inside the matrix. And there, in the rows, we will be finding the length of the matrix in the rows length of the matrix. And for the columns, in column there are variables. These are variables. Int rows is equal to matrix dot length, and this is other matrix column is equal to matrix 0 of length. In this will be declaring the first initial matrix, initial column, 0th column. Here int open and close square braces, named as transpose matrix. We have named a new matrix, transpose matrix. We having a new, we are defining it as new matrix, which we are initializing it. So we are writing like this: int columns and rows. We are transposing the rows of this matrix and columns of this matrix to the columns and rows. Now we will be conducting two for loops, one for loop inside the other for loop, and performing the operations as for first for loop for I less than zeros. For rows we have defined rows, and for rows less than rows, and for columns j less than columns for this I less than rows, and I less than columns for loops. Similarly, for transpose, I of j, j of I should be the matrix of I of j. For the transpose, j of I, j of ji, matrix transpose of ji, transpose of ji. Matrix ij will be transposed as ji. Matrix ij will be transposed as ji, and the output will be printed as system.out print original matrix. This will be first printing the original matrix, and after that print matrix transpose matrix matlab original matrix. This will be printing the original matrix, print matrix and after this, to display the matrix, this will be displaying the original matrix, and to display the transpose we will be commenting it as transpose matrix. After that we will be printing print matrix, and this will be the transpose matrix, and after that we will be printing it. Method to print the matrix, method to print the matrix. If the rows of the lies in the matrix and the columns lies in the values of the rows, this states that if the rows lies in the matrix, and for the columns, for the values of the rows, system.out.println and system.out.println for the next line. This will be in the same line, and this will be in the next line for print. For this is showing as println. This will so for moving to the next line. Now when we run our program, we'll be seeing the output on the console. 1 2 3, these are the entered matrix which we have taken the value originally 1 2 3 4 5 6, and this is the transpose of the matrix. So it's clear that the matrix can be transposed, and this can be formed by the operations which we learned. Now let's perform the other task of matrix multiplication. For this we will be going to this folder only, this trident folder. We will be double clicking on it, and then we will go to the new, where we will be naming the class as matrix multiplication. Matrix multiplication. That's it, and we should be finishing it. Now this has created a public class matrix multiplication class, whose first letter is in capital letter. Class name is first letter is in capital letter. This is an open and close open square braces, followed by matrix1, which is the variable name of this matrix, followed by the data inside it, and the second matrix, followed by the data inside it. Similarly, we will get the sizes of this matrix. Matrix 1, rows 1, row 1, matrix 1 dot length, and row 1, column matrix 1, it's 0th column dot length, and row 2, matrix 2 dot length, and column 2, matrix 2 dot 0th dot length. Now if we check multiplication is possible or not, for this, number of rows, number of columns will be number equal to, for multiplication to be possible, number of columns is equal to number of rows, then only it can be multiplied. If it is not, then multiplication cannot be done. To check for this, we will be going for the checking this condition, and for this, if columns not equal to number of rows in this, is multiplication is not possible, and system.out.println multiplication is not possible, return, then the value is returned to the original value. Without multiplication, it will return to the initial start point, and if it is done, then the result will be shown in this form, where the rows and columns, when the columns of the second one is the columns of the first one, rows of the first one, and then the rows of the first one, and the columns of the second is showing here. Now we will be multiplying these matrices as done here. 0 for loop inside the for loop inside the for loop. First for loop should go less than equal to row 1, and second one in j is less than column 1. And for the multiplication, we have the other variable k0, k1, and k2, where result of ij plus it will be multiplying and adding, multiplication and adding, matrix 1 of ik, matrix 2 of kj, and finally the result printout is here. System result of the matrix, result system println result of the matrix. Yeah, for here also we need to print the values for the two rows and columns. For this we will be printing I and j, k of I and j of result dot length and result of 0 dot length. This will show us the values. For this we will be printing system.out.println result of ij, and then we will be printing system.out in the opening closing the curly brace. Afterwards we will be printing system.out.println for moving to the next line. Finally we will be running this program and we will seeing the output on the console. Yeah, it's very well, it's shown here. Yeah, all the matrices, they are shown here. The value of these matrix and this entry in this matrix. Yeah, thanks.